So another type of question that could be asked in regards to the triangle congruence theorems is using this standard where we have to use the definition of congruence in terms of rigid motions. We have to refresh on what rigid motions are. So the directions for these types of problems, I'm telling you that the triangles are congruent. So it's not a yes or no. They all will be congruent in these types of problems. But we have to tell why using the appropriate theorem. Remember, our options for theorems are side, 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 angle, angle, or angle, angle, side. So those are our 4 options for this for these problems. But we also now have to say, well, which rigid motion was performed? So we did rigid motions first semester, and they were translations, rotations, and reflections. So if you're trying to decide if something's a translation, translation is similar to a shift. We're taking our original figure and we're shifting it either to the left, to the right, up, or down. If we're looking at a rotation, we're looking, did the figure rotate or did it turn in either a clockwise or a counterclockwise rotation? And if we think it's a reflection, another way to think about reflections is flip. Does it look like the triangle flipped over something? If I were to fold the triangle over on top of itself, would all the sides and angles match? So we have to do 2 things. I'm telling you they're congruent, so we have to decide, well, which theorem proves that statement that they're congruent? And we have to decide, well, which rigid motion was performed on these triangles? So if I look at this first one, okay, we talked about on the front page that if these triangles share a side, then they have to be congruent to each other. So I'm going to add a tick mark there to show that I know that whether I'm looking at the one on the left or if I'm looking at the one on the right, that side's going to be the same length and be congruent. So if I'm looking here, I have a side with a tick mark on both. I have a side with 2 tick marks on both. And then I also have a side with 3 tick marks on both. So since in each triangle I have 1, 2, 3 sides labeled, there's no angles marked, so it has to be the side, side, side theorem. So the next part is the rigid motion. So we have to go through. Does it look like this triangle is the same exact triangle? It just shifted over. And the answer is no, because if that was true, the side with 3 tick marks is on the left here, it would be on the left over here. So the next we want to see, well, did it rotate? Did it turn? Did I take this first triangle and turn it around? And again, the answer is no. I did not rotate it in a circular motion. So the last option is a reflection or flip. If I were to take this triangle and flip it or fold it on this line that's shared between them, the 2 sides that I highlighted in pink would match up and the 2 sides that I highlighted in yellow would match up. So that is what tells me that this is a reflection. The next one. So similar to the last problem in the last video that we did, we have 2 triangles that share a vertex right here. And these angles that are formed are vertical angles. They're across from each other when we have intersecting lines. And vertical angles, we learned, are congruent. So I'm going to mark those congruent. So I have a side, or I'm sorry, we have an angle marked with 1 arc on each triangle. We have a side with a tick mark on each triangle. And then I also have these vertical angles in each triangle are congruent. So I told you they're congruent already. We had to figure out which theorem. And if I'm looking here, I have 2 angles in each one. So that kind of leaves us to these last 2, angle, side, angle, or angle, angle, side. And again, the way we know is we have to see, is the side included or not included? And in this case, the side is included between these 2 angles. So that would make this congruent by angle, side, angle. So the next part, the rigid motion. So if it was a translation, it would look like I took this triangle and I just moved it over. So the pink angle would be in the same spot on this triangle, and that's not the case. For a rotation, I would take this triangle and rotate it and turn it, and it looks like it did that. It looks like it took this triangle and turned it in that direction, clockwise. So this is a rotation. We'll do a few more. So I'm going to look at this one. Whoops. We're going to look at this one next. So again, analyze what you're given. A side with a tick mark on each one. A side with 2 tick marks in each triangle. And a right angle in each triangle. So I have 2 sides and an included angle marked in each triangle, which makes these 2 triangles congruent by side, angle, side. Now in terms of rigid motion, this would be a translation because I took this triangle and I just moved it over to the right. You notice the side with 2 tick marks is in the same exact spot on this one. The right angle's in the same exact spot. This side's in the same exact spot. Nothing turned or flipped, so this it would be a direct translation, or it's shifted over. So translation. So those are the 3 options. So we did an example of a reflection, we did an example of a rotation, and we did an example of a translation.